In this video, we are going to find the absolute extrema of two different functions on two different intervals. So our first function is f of x equals x e to the negative 0.5x, and our first interval is 1, 3. So we are going to do this by finding the critical numbers of this function, and then we're going to evaluate the function at the critical numbers at 1, which is the left boundary, and at 3, the right boundary, and whichever is smallest is the absolute minimum, and whichever is largest is the absolute maximum. So let's take the derivative. So f prime of x, we're finding the critical numbers. This is a product rule, so we get e to the negative 0.5x minus 0.5x e to negative 0.5x. We set this to 0 equals e to the negative 0.5x minus 0.5x e to the negative 0.5x. And we recognize that this function, the e to the negative 0.5x, is never 0, so we can factor it out. E to the negative 0.5x times 1 minus 0.5x. And the only way for this function to be 0 is the right-hand term to be 0, so that is x equals 2. So now we evaluate our function. This isn't going to work very well, but f of 1 is equal to e to the negative 0.5. F of 2, that's our critical number, equals 2 e to the negative 1, and f of 3 is equal to 3 e to the negative 1.5. And so now I've got to decide which of these is biggest and which of these is smallest. And I cheated a little bit. I would plug these into my calculator to see what they are. And so I did that a little earlier and figured out that f of 2 equals, we'll write this as 2 over e, is the absolute maximum. And f of 1 equals 1 over the square root of e is the absolute minimum. I'm not good enough with my e's to be able to figure out which of these and what order these are in. All right, so now the second function. We're going to do f of x equals 3x cubed minus 2x on the interval negative 3, 0. So we take the derivative, same strategy, f prime of x equals 9x squared minus 2. Set this to 0 so we can find the critical numbers. 0 equals 9x squared minus 2, which would mean x equals plus or minus the square root of 2 over 3. Now we have two critical numbers, but only one of them is in our interval, so all we really care about is x equals minus square root of 2 over 3. Okay, so now we need to figure out our function values. So f of negative 3 is equal to 3 times negative 3 squared minus 2 times negative 3. So this should be a cubed, sorry. So this is negative 81 plus 6, which is negative 75. Okay, f of 0, I'll do quickly, that one's easy, is 0. And f of negative square root of 2 over 3 is equal to 3 times negative square root of 2 over 3 cubed minus 2 times negative square root of 2 over 3, which is, let's see here, we've got a 3 squared left in the denominator, and we have a negative 2 root 2 over 9 minus, plus 2 root 2 over 3, multiply top and bottom by 3 here, and we get a 6 over 9. 6 minus 2 is 4, so we end up with a 4 root 2 over 3. So looking at this, 4 root 2 over 3 is our absolute max, and negative 75 is the absolute min. And so this is our strategy for these types of problems. If we have a closed interval, we first find the critical numbers, any critical numbers within that closed interval, and then we evaluate the function at the boundaries and at the critical numbers. The largest number is the absolute max, and the smallest number is the absolute min.